Now, the first objective is just you and I trying to understand what we mean by conic sections. So here's a brief little introduction of why we call them conic sections. Um, we call them conic sections because each of these shapes are the results of the intersection between a right circular cone. So you see a right circular cone here, right? And a plane. And depending on how the plane intersects the cone will determine what kind of conic you get. All right? Really, it's the angle of the plane that determines the conic that you get. So if the plane hits the cone just like this is the circle. This one's the parabola. Notice that you just have one branch like this. We've studied parabolas in previous lessons. This is a hyperbola. It kind of looks like you have two branches here. I mean, you do have two branches. It looks like you have two parabolas. And then you have an ellipse here. Many times people call the circle a perfect ellipse. It's a special kind. The circle is a special kind of ellipse. But anyway, these are the four different kind of conic sections that you and I will walk through, and they're called conic sections again because it's the intersection between a circular cone and a plane. All right, let's get into a circle now. Okay. The definition of a circle is a set of all points in a plane that are equidistant, meaning the same distance, from a fixed point. The fixed point is called the center of the circle, and the fixed distance is called the radius. So all of these points on the circle, folks, all of the points on the circle have something in common. Oh, here's one point I've called out at random, point P. But all the points in or on the circle have something in common, and that is they are the same distance from a fixed point. All of them are the same distance from the center, a point called the center. All right, the center is a fixed point. It's important to notice that the center is not part of the circle. The center is not on the circle, I should say. But all of the points on the circle are the same distance from the center. We call the center the fixed point, and that distance, that fixed distance, is called the radius. R for radius. All right. Okay, now in order to derive the standard form for the equation of a circle, we're going to use something called the distance formula. It might have been a while since you've seen this formula. This formula says that the distance between any 2 points in the plane, in the Cartesian plane, is equal to the square root of the sum of the squares of the differences between the x coordinates and the y coordinates. Okay, so that was a mouthful. So basically, you have 2 points here, and the 2 points that we want to plug into the distance formula is the point for the center and this random point on the circle, x comma y. All right, so let's plug those numbers in. So one of my x coordinates is x, and the other one is h. X and h. I'm going to plug those in, and the distance formula says I need to subtract my x coordinates, and then it says I need to subtract my y coordinates. One of my y coordinates is simply called y, and the other one is called k. What does this give you? It gives you the distance between the center and this point. But we already know the distance between these 2 points is that fixed distance called r. For the left-hand side is r. Now what I would like us to do is consider squaring both sides. If you square both sides, then the square root on the right will go away. Of course, the left-hand side would be r squared. R squared is equal to, and then x minus h quantity squared plus y minus k quantity squared. All right, now what we've just derived here, I'll write it out one more time. This is, ladies and gentlemen, the standard form for the equation of a circle. I think it's so important that you and I are extremely familiar with this equation. This is the standard form for the equation of a circle. All right. Now, there's a few things that you want to make sure you take note of. Number one, h and k. h comma k, if I can scroll up for you a little bit, just enough to see that h and k, don't forget, they represent the coordinates for your center, for the center of the circle. This number, comma, this number represents the ordered pair for the center of the circle. The second thing I want us to realize is that this whole equation is set equal to the square of the radius. It's not set equal to the radius. It's set equal to the square of the radius. So be very careful. So here it is, folks, the standard form for a circle, and h comma k is representing your center and r is representing your radius. Now we are ready for our first example. All right, first example, find the center and the radius of the following circles. So here's the first circle they want us to find the center and the radius for. Now, what I want you to do is consider that this can be rewritten, if you'd like, as x minus 0 squared plus y minus 0 quantity squared is equal to 4 squared, right? So then you can see your h and your k are both 0, and your radius is 4. All right, so the center is basically the origin, and the radius is 4. Okay, now what I would like us to do now is go ahead and graph this circle. All right, so we're going to need a little space here. Let me move this up a little bit. All right, so let's get our plane started here. All right. Now notice that I scaled my axes out to 4 units for all of them. I think you know why, because the radius is 4. Okay, so I always like to plot my center first, which is the origin, and then the radius is 4. So all I'm going to do is move out 4 units. Move out 4 units to the left, move out 4 units to the right, and up and down from the center. So if I'm at the origin and I move 4 units to the right, that puts me here at 4, 0. If I move 4 units to the left, it puts me at negative 4, 0. If I move 4 units up, I get 0, 4. If I move 4 units down, I'm at 0, negative 4, right? And so then your circle looks something, and I mean just something like that, right? Please be very forgiving about my circles, okay? I did that by hand, so it does look a little sloppy. But this is what the circle would look like. Here's our next example. Let's not forget what the instructions said. The instructions said to find the center and the radius for the circle, all right? Now, this says x plus 2 quantity squared plus y minus 1 quantity squared is equal to 9. Now, what I want you to notice is that in the standard form, which I've written in green here just to remind you, you have x minus h, you have y minus k. Because of those expressions, we're going to take the opposite number that we see. We did a similar thing when we were studying parabolas. So because I see x plus 2 here, I know my center is really negative 2. And then I see a minus 1 here, so I know the second coordinate of my center is positive 1. Negative 2, positive 1, all right? So I've written down the center as negative 2, positive 1, and notice that I wrote the radius as 3. Because remember, 9 is not the radius. 9 is what you get when you square the radius. So I want you to be thinking, what number do I square to get 9? Oh, 3. Or if you'd like, whatever number this is right here that the equation is equal to, just take the square root of that number. So r will be equal to the square root, the principal square root, which would be the positive square root of 9, which would be 3. You can always do this if you want. Just take the square root of this number, take the principal square root, the positive square root that is, of this number, and that'll give you your radius, all right? All right, let's graph the circle. Now notice that your center is in quadrant number 2, and you're going to be moving up and down, left and right 3 units, all right? So keep that in mind. So let's do something like this. And then something like this might be good. Let me scale my axes now. All right, so I notice my center is negative 2, 1, which is about right here, okay? And then I want to go to the left, to the right, up, and down 3 units. When I go to the right 3 units, it drops me off at 1, comma 1. That point's on the circle. When I go 3 units to the left of the center, I end up at negative 5, comma 1. That point's also on my circle. When I go up 3 units from the center, I end up at negative 2, comma 4. When I go down 3 units from the center, I end up at negative 2, negative 2. Okay? And hopefully this looks like a circle, okay? Of course, we're doing this by hand, so we're going to be very forgiving of our circles, but that would be what the circle will look like. Of course, if you want to use a graphing calculator, or if you want to, there's an online calculator at desmos.com that you could always use to get a nice picture. All right, you guys, our next question. X minus 3 quantity squared plus y plus 2 quantity squared is equal to 11. Now, if you remember what we said a few minutes ago, we want to take the opposite of what we see, right? So here, because I see negative 3, I'm going to say my center starts at positive 3 and then negative 2, okay? Positive 3, negative 2. That's in quadrant number 4. Now the radius is going to be the square root of this number that we see on the end, the principal square root. All right, so we know the radius is going to be equal to the square root of the principal square root of 11. And it might be helpful to know that this is approximately equal to 3.32. You can punch that into your calculator to confirm. Now, because our radius is the square root of 11, I think we need to be just a little careful here. We're going to start with, do you remember how to find those 4 points that we're using to draw a circle? We start with the center, and then we move our number of units, which in this case is the square root of 11, to the left, to the right, and up and down. All right, so then this is what we'll do. When we start with the radius, and when we move to the right, that means we're adding the square root of 11, right? And then comma negative 2. That'll be one of the points. Another one will be found by subtracting. That'll be moving to the left, right? And then when we move up from the center, we are changing the y-coordinate. So when you move up, you'll be adding the square root of 11. And then when you move down from the center, you are changing your y-coordinate and you are subtracting the radius, right? So this is how we're finding each of these points that we're going to use to draw a circle. Now, this is approximately equal to 3 plus, the square root of 11 is about 3.32, like this. This one would be 3 minus 3.32, comma negative 2. Oh, these are, you know what, I think I started by saying approximately, maybe, but I want to really emphasize that these are approximately now because we're using an approximation for square root of 11. This will be 3 comma negative 2 plus 3.32, and then this one will be 3 comma negative 2 minus 3.32. And again, these are approximations, okay? So then these 4 points will be, all right, there, I did the arithmetic, and these are the 4 points that I'll be using to plot my circle, to graph my circle. All right, so let's move this up, shall we? And let's see. Okay, I've scaled out my axes. My center is 3, negative 2, so let me plot that. And then basically, you know what I want to do is I want to highlight the center with a different color. Let me just use, I don't know, red or something. 3, negative 2. There's your center. Okay, let's plot these 4 points that we got. Let me remind you how we got these 4 points right here. We started with the center, and we moved to the left, to the right, up and down square root of 11 number of units, which is basically 3.32 number of units. Now, I'm going to eyeball this a little bit, okay? So one of the points is 6.32 and then negative 2. So 6.32, negative 2 is maybe about right there, okay? We have negative 0.32 which is really close to 0, and negative 2. Okay, so maybe about right there. Okay, give or take. And then we have positive 3, comma 1.32. So positive 3, comma 1.32. And I just realized I forgot to scale my axes up here. So let's call that 1. So 3, comma 1.32 is up there somewhere, right? And then finally we have positive 3, negative 5, 0.32. Okay, so maybe about right here. Of course, on a graphing calculator, this would be a lot better, of course, right? Using a machine. Okay, that looks like a funky circle to me, but anyway, yours probably looks a lot better because you're probably using graph paper, right? And a ruler, and so your circle probably really, looks really nice. If we had a compass would really allow us to make a really accurate circle. I don't have that, so just bear with me as I get these circles, or they're supposed to look like circles, up on the board, okay? Okay, guys, this is our next equation. And again, the instructions are to find the center and the radius of the circle, and then maybe we can try graphing it. Now, as you can tell, this is not in standard form. Can I remind you what standard form is? This is standard form. And the main thing I want you to take away by looking at this is there's only one variable x and one variable y. But here you have an x here, you got an x here, you got a y there and a y there. So really what we want to do is we want to get this perfect square in x and a perfect square in y. In other words, complete the square in x and complete the square in y, and then you'll get these perfect square, the square of these binomials here, okay? So let's complete the square in x and complete the square in y. All right, so in order to complete the square in x and y, the first thing I'm going to have you do is use the associative property of addition to group the x terms together and group the y terms together. Okay. While we're at it, let's move that constant, which is 18, over to the other side. So now it's negative 18. And now I want you to complete the square in x and y. Let me remind you how that goes. This is where you take half of 10. It's really half of the coefficient of the first degree term. This term here is first degree because the power right here is assumed to be 1, right? So this is first degree. Take the coefficient only and divide by 2. Same thing over here, negative 6 divided by 2. Okay, I'll get there. So 10 divided by 2 is 5. And then what you want to do is square 5 now. Square 5, which gives you 25. I hope you remember doing this when you and I were dealing with or working with studying parabolas. Same thing over here. Take negative 6 divided by 2, which is negative 3. Take negative 3 and square it. Okay. These two numbers here, 25 and 9, are going to be the two numbers that you're going to add inside of these groupings. So you're going to add a 25 right here and add a 9 right there. Okay. So then you would have something like this. You would have x squared plus 10x plus 25 plus y squared minus 6y plus 9 is equal to negative 18. Now, this is really important. If you added 25 and 9 to the left-hand side of this equation, then you have to add 25 and 9 to the right in order to keep things equal. So, actually, let me make a little more room over here on this side. What we need to do, let me rewrite that, negative 18, just a little smaller. If we added 25 to the left, you have to add 25 to the right. If you added 9 to the left, you have to add 9 to the right as well. Okay, so you see me doing the same thing to both sides. Now, this is a perfect square trinomial. This is. So that means it factors as the square of a binomial. So like this. The variable that we have in this grouping is x, and then the middle sign, the sign on the middle term, comes down right here. And then what number do you square to get 25? What number do you square to get that number? 5. And then square that. plus, over here the variable is y. Oh, I made a mistake. I'm sure you guys caught that mistake earlier, didn't you? This should be this variable here. It's kind of embarrassing. That variable should be a y, right? Can you guys change it in your notes? Okay. I bet some of you were yelling at me like, hey, that's supposed to be a y right there. I'm glad we caught it. Okay. So the variable is y, and then the sign on the middle term comes down. Since that's negative, you're going to get a negative in the middle. And then what number do you square to get 9? 3. And don't forget to square that. Okay? And then the right-hand side, just go ahead and add negative 18 plus 25 plus 9. I believe that's negative 18 plus 34, which will be 16. 16. All right, good. All right, guys, this is great news because now we can see what our center is, right? Instead of writing out the whole word center, I'll just write a C, okay? And instead of writing out the word radius, I'll just write out the letter R for radius, okay? So we can see, remember, don't forget that we take the opposite of what we see. So then the center is what? Negative 5, positive 3, and the radius is the number whose square gives you 16, which is 4. So there's your center and your radius. So in order to figure out, this was standard form, by the way. This is what you and I worked really hard to get. So you and I had to work hard to get standard form. Once we had standard form, then we can identify what the center and the radius is. Let's go ahead and graph this circle now. Okay, do you remember how you're going to get your points on the circle? You're going to start with the radius, you're going to start with the center, and then you're going to move 4 units to the left, 4 units to the right, 4 units up, 4 units down. Now, when you move 4 units left from the center, that means you are subtracting 4. When you move 4 units right, that means you are adding 4. When you move 4 units up, that means you're adding 4 to the second coordinate. And then when you move 4 units down, that means you're subtracting 4 from the second coordinate. So then, your points here are going to be negative 9, 3, negative 1, positive 3, negative 5, 7, and negative 5, negative 1. All right, this really helps. So we're going to take our center and some points on the circle and then just go ahead and draw the circle. Okay, guys, I scaled out my axes. I plotted my center at negative 5, positive 3, and I plotted each of those 4 points that you and I just finished gathering. And so then the hardest part for me is making this look like a circle. So if I go really fast and like squint my eyes, it looks like a perfect circle. All right, so there's my ugly circle. But anyway, I think you get the idea, and I think you understand that I'm graphing by hand without a ruler and without graph paper. And so I think, I think we'll be very forgiving of our each other's circles. But the main idea that I want you to really, really focus on is how we had to complete the square in order to get the standard form of the equation. Cool, let's move forward. Okay, guys, this equation is similar to the previous in that it's not written in standard form. So let's complete the square in x and in y in order to get standard form. All right, so let's collect our variable terms. Let's collect our x terms together. And let's collect our y terms. Actually, there's only one y term. Okay, and let's move the 18 over to the other side. Okay, now let me show you completing the square. When I take half of 8, I get 4. And then when I square 4, I get 16. So I'm going to add 16 inside that first group. Okay. You're not going to do anything with y squared because it's already a perfect square. And then you just have negative 18. And then you have to add 16 over here. If you added 16 to the left, you have to add 16 to the right as well. Okay. Now let me make some space here. That's gone. Now, this is x plus, and the number whose square gives me 16 is 4, plus y squared, is equal to -2. Now, this here is supposed to be your radius, correct? Or I'm sorry, excuse me, it's supposed to be the square of your radius. So then the radius is equal to the square root of -2. But this is not a real number. I'm going to just put it's not real, right? And because that's the case, then this equation here, x squared plus y squared plus 8x plus 18 is equal to 0, does not give you a 0. Because this is impossible for the radius to be a distance that is not a real number distance at all. Then it's not, this equation does not produce the graph of a circle at all. It's actually called a degenerate case. Okay, so actually, let's make some conclusions here, some observations before we move to another objective. So when you are working with these equations and the right-hand side, r squared, turns out to be a positive number of some sort, then you have a circle. But if r squared is 0, then all you have is a point. It's not really that interesting. It's just a point. That's all you have. Basically, that point is the center, okay? If r squared is negative, like our previous example, r squared was -2, right? You have no graph existing at all. There is no graph, okay? All right, look at this example. Find the equation in standard form of the circle having center at 2, -5 and radius equal to 6. Hey, by the way, guys, I don't know if you even noticed, but the previous example was labeled example 1, and now we're at example 3. So if you're taking really good notes, you might be wondering, where's example 2? I took example 1 and example 2 from the book, and I combined them to be one example. So don't worry, we're not skipping anything. Okay, I think what should really be our first step here is to write down the standard form of a circle. Do you remember what it is? I would actually suggest or recommend that you pause this video and come up with the standard form, write it down, of a circle all on your own. Okay, so I hope you did that, and I hope that you wrote this. X minus h quantity squared plus y minus k quantity squared, let me make that a little neater, y minus k quantity squared is equal to the square of the radius. That's the standard form for a circle. Now, what I want you to notice is that they gave you the center already. It's 2, -5. So 2 is your h value, and -5 is your k value. And then your radius, r, is 6. They already labeled it with r. So then I'm just going to plug everything in. So then this is x minus 2 quantity squared plus, and be careful right here, y minus, and then a -5. Did you catch my sign right there? Be careful. The negative right here, that negative comes with the standard form, and then the negative that's on the 5 is because that coordinate's negative. Now don't forget, this whole equation must be set equal to the square of the radius, so 6 squared. All right, so then the final answer would be x minus 2 quantity squared plus y plus 5 quantity squared is all equal to 36. We're done. So this is a standard form for a circle whose center is 2, -5, and radius 6. Not that bad, right? Just kind of plugging in what they gave you and finding the standard form. Okay, cool. Let's go to the next example. Look at this one. Find the equation in standard form, of course, of the circle with center -3, 1. Let's stop right there. If they gave us a center, then that means -3 is my h value and 1 is my k value. And with the circle passing through the point 1, 5. Now, 1, 5 is not your center. They were really clear about what your center is, right? This point right here is just a random point that your circle goes through. So then this is an x, y, an x, y value. X is 1 and y is 5. So what is not given is the radius. All right, so I suggest that our starting point is the same as the previous question. Let's start with standard form for a circle. Okay, this is what they're asking for. Now, what they gave you is h, k, an x, and a y. basically they gave you enough to plug in for everything on this side. The only thing that's missing is r. So my strategy is, why don't we plug in everything they gave us over here, simplify it, and then we'll find r. So that'll look like this. So then we'll have plugging in 1 for x and plugging in -3 for h. Don't forget, standard form says you have to square that. Hey, did you guys catch that right there? My x value is 1, see right here? And my h value is -3. So I'm plugging in those two values for x and h. Plus, and then my y value is 5 minus my k value, which is 1. Square that. And don't forget, this is all equal to r squared. So then this is 1 plus 3, quantity squared, plus 4 squared, which is equal to r squared. So this is 4 squared plus 16 is equal to r squared. 16 plus 16 is equal to r squared. That is 32 is equal to r squared. And that's enough. Don't feel the need to take the square root of both sides, because remember, all they're asking you is for the standard form of the circle. And standard form is always set equal to r squared. Not to r, but to r squared. We have r squared, so I think we have everything we need to write down our final answer. All right? I'll change the color just for our final answer. Our final answer will be x minus, remember what your h value is -3 squared. Let me clean that up just a little bit there. Okay, I ended up erasing more than I wanted here. So then this is -3. Okay, plus y minus your k value, which is 1, and r squared is 32. I guess we're done, but I just want to clean this up a little bit. So it's x plus 3 quantity squared plus y minus 1 quantity squared is equal to 32. Remember, 32 is r squared, right? 32 is the square of your radius. So that's the standard form for the circle. Again, I think the whole strategy is basically just plug in what they gave you. Just make sure that you plug everything in the correct spots, plug in the correct numbers for the correct variables, and solve for whatever it is you're missing. In this case, it was r squared. All right, cool. Let's go to the next example. Now this one's interesting. Find the equation in standard form of the circle with a diameter having endpoints 2, -5, and 6, 1. I think for this one especially, we're going to draw a picture to get a visual. So here's my Cartesian plane. I have those endpoints for the diameter, and we know the circle goes through these 2 points. So then we have something like this, okay, everybody? And remember the definition for diameter? Diameter is a line, a segment of a line that goes from one end of the circle to the other through the center. One more time. A diameter of a circle is the line segment that goes from one end of the circle to the other end of the circle through the center. Okay? That means this here, if this is your center somewhere here, now we don't know where the center is, but we do know that this segment here goes right through your center. Okay, this is the diameter. So this is the picture they gave us. They want us to find the equation in standard form. Now, what two things do you need for the standard form of a circle? Well, we know that our final answer is going to look like this, right? This is standard form for a circle. So I hope you see that the two pieces of information that we need is, number one, we need to know what the center is. Right now we don't know what it is. And we need to know what the radius is. We need to find the center, and we need to find the radius. Now, these two are the endpoints. 2, -5, and 6, 1 are the endpoints of the diameter. The diameter, by definition, goes right through the center. So this is what I'm thinking. The center is right in the middle of this segment, right? So So if we find the midpoint, we find the center. There is a midpoint formula. Basically, the midpoint formula gives us the average of your x coordinates and your y coordinates. Now, I need some room to show you the midpoint formula. Let me do this, folks. Let me erase this down here. And I need to create some space, all right? But I know that for the midpoint, I'm going to need my 2 points of the end of the diameter. So actually, I think what would be a good idea is if I label this 6, 1, and I label this point here 2, -5. We need those 2 points in order to find the midpoint. All right, here's the midpoint formula, folks. The midpoint, I'm going to just call it M, okay, is going to be your first one of your x coordinates plus the other, and then divide by 2, and then it'll be the sum of your other 2 y coordinates divided by 2. So let's plug this stuff in. The midpoint is your x coordinates are 2 and 6. We have to add those. 2 plus 6 divided by 2, comma, and then we have to take our y coordinates, add them together, and divide by 2. So -5 plus 1. And divide by 2. All right, let me move this up. What we get right here is going to be the center, okay? So you're going to get 8 over 2, comma, -4 over 2. So our center is going to be 4, comma, -2. This is our center, you guys. This is our center, which is the midpoint of the diameter of the circle, okay? This is our center. -4, or +4, -2. Cool, we have our center. Do you remember the other thing we needed? We needed the radius. But look at this. I think we have enough to go to the standard form for the equation of a circle. And plug in what we found. We know now what h and k are. We know what h and k are. This is h and this is k, right? The center of your circle. In addition, do we have an x comma y? Do we have a point on our circle? Well, absolutely. Actually, we have a couple points. We get to choose. Do you want to use that point as your x comma y, or do you want to use this point as your x comma y? I'm going to use 6, 1 because both of the coordinates are positive, so I don't make a sign error. So I'm going to use 6, 1 for my ordered pair. Okay, you guys, 6, 1, let's be really clear. This point on the circle was given to you. But this point here we found, the center we found using the midpoint formula. All right, let's plug our stuff in, all right, shall we? So then this is going to be 6 minus 4 squared plus, let's see, 1 minus -2 squared is equal to r squared. All right, did you guys catch what I did? This is x minus h. This is y minus k. All right, cool. Now let's solve for r squared. So then this is 2 squared plus 1 plus 2 squared is equal to r squared. So then this is 4 plus 3 squared is equal to r squared. 4 plus 9 is equal to r squared. 13 is r squared. Now, don't take the square root of both sides because they never really explicitly said find the radius. They said find the standard form for the circle. So now we have everything we know, everything we need. So then we have x minus our h value. Let me move the screen up a little bit so you can see it. Do you see it right there? H and k. Let's plug those in. This is our final answer, folks. X minus h, which is x minus 4 quantity squared, plus y minus k, which is y minus -2 squared, is equal to r squared, which is 13. I guess you're probably expecting me to clean this up a little bit, which I will. X minus 4 quantity squared plus y plus 2 quantity squared is equal to 13. This is the standard form. Whoa, sorry, I don't know what's going on. This is a standard form for that circle. Okay, everybody? That one was definitely the most work, but it still wasn't that bad.